Okay, so it says that in a survey, 12 people were asked how much they spent on their child's last birthday gift. The results were roughly bell-shaped with a mean of 45. So this is X bar because it's based off of the sample, and this is S because it's based off of the sample. Construct a confidence interval at the 98% confidence level. So I'm just going to dive right into it. Since we don't know sigma, we're going to use a T interval. Stat over to tests, T interval. I'm entering stat. X bar here is 45. S is 9. N is 12. And the confidence level is 0.98. I think you might have just did some small calculation error. So my point estimate, absolutely perfect, is 45. Plus or minus, what am I adding and subtracting to get these two numbers? We'll take the top number, 52.062. 52.062. And subtract the point estimate, 45. You actually get 7.1. So the answer here should have been 7.1. I think it might have just been a small calculatory error. But all right. You want to obtain a sample to estimate a population mean. Based on previous evidence, you believe that the population standard deviation. So we have sigma. You'd like to be 98% confident that your estimate is within 0.5 of the true mean. So we have everything we need. First thing I want to find is the z-score that cuts off the middle 98%. So I'm looking for the z values. Z and z that cut off the middle 98%. So if there's 98% in the middle, that means there's 2% divided outside here. So this is 1%, and this is 1%. So when I find the z-score, I'm going to go to inverse normal. And it wants the area to the left. I'm looking for this is negative z. I'm looking for this z value. So I'm looking for the area to the left of this. 98 plus 1 gives me 99. So this is going to be 0.99. 0.1 because it's standard normal. I get 2.326, whatever, that's fine. So I'm just going to use that number. That's this z value right here. Okay. So the next thing I do is I take that, I multiply it by my sigma, 27.1. That's my numerator. Divide that by my margin of error. So I'm going to divide that by 0.5. And then I'm going to square that whole thing to see the answer and square it. And you should get 15,898.1. But whenever you're looking for a sample size, you always round up. So this is going to be 15,899. And that's your answer.